Please share the convertings in the chat. Topic is organic chemistry, nothing but study of organic compounds. So what is organic compound? We will change looking in the next slides. In the organic chemistry, I started organic chemistry, which is called chemistry. First, know the small subtopic, that is general organic chemistry. In that, you have 7 topics. Out of the 7, the first we are going to start, that is nomenclature. So the top overview of the session is, first we'll be having the introduction of organic chemistry. That means how the word organic came, who derived the meaning, what do you mean by this? Then next we'll talk about the classification. So organic compound will classify into how many types and based on what. The next is UPAC nomenclature, that means how to give the name, that too for hydrocarbon. Next is we'll have certain factors, and PQs will delete as of now. Then we have homework. So as of now, we'll start moving to the introduction of organic chemistry. So what is organic chemistry? It's nothing but a chemistry of carbon compounds. So wherever you study carbon compounds, please call that compound as organic compounds. And the chemistry, you should call the chemistry as organic chemistry. So please remember, carbon compounds, organic compounds, and the chemistry is known as organic chemistry. So see, the word organic is derived from, I think you might know very well about the word organic. The word of here, organic chemistry, the word organic came from the word called as living organisms. So you know, there is a scientist called as Berzelius. He said living organisms are made up of chemicals which are made up of carbon. So all compounds which are found in living organisms are made up of carbon. Example, carbohydrates. So you might say, what are carbohydrates? Please, simple thing to remember, carbohydrates they usually end with osma. For example, you know very well that are glucose, fructose, sucrose, xylose, ribose. So many of them usually end with O's. Example, I can give you one example is C6H12O6. So you can say that carbohydrate, you take this is example of glucose, right? You take fructose, you take sucrose, any carbohydrate you take, all are made up of carbon. So you can say that carbohydrates which are found in our body are made up of carbon. The next, other important compounds which are found in our body are proteins. You know, right? During the building block of our body, you know, proteins are made up of small units called as amino acids. The name says amino acids. They are made up of amino group and acid group. If you see amino acid, they are also made up of carbon. And next is you take vitamins. You know, right? Daily we take vitamins like vitamin A, D, E, K, vitamin B and C. All are made up of carbon. Next you take hormones. You know, our body's proper functioning and growth of the body requires hormones. So in our body, there are hormones like growth hormone, follicle stimulating hormone. There are many hormones which are made up of again carbon. The next, enzymes, again they are made up of carbon. Next, nucleic acids which makes you unique, right? So what are unique nucleic acids? It can be DNA or it can be RNA. You take, again they are made up of carbon. And the last is lipids. Usually lipids are 3 types. The one is known as wax, the next is oil, and the third is fat. You take all these are in a body, which are found in a body, are made up of carbon. So Berzelius said that organisms are totally made up of carbon compounds, and these molecules which are found in a body are called as biomolecules. And you know what about these biomolecules, from each carbohydrate to the till lipids, we'll be studying about this in a separate chapter called as biomolecules in organic chemistry, which is almost the last part of organic chemistry. So Berzelius said found in organisms, the vital force which is present in forming carbon compound. Special force laboratories, because you cannot create the similar vital force which is found in the human body in the laboratories. You cannot create that force. Hence, carbon compounds cannot be synthesized. He said these were the two postulates of Berzelius, and this theory is known as vital force theory. So, as he said, talk about vital force, therefore the name of this theory is known as vital force theory. The next, after a long period, this theory was dominant for a long period. Dominant means it was existed for a long period. But after a time, a scientist called as Wöhler, he accidentally synthesized a carbon compound called as urea from ammonium cyanide. You know what? He was doing an experiment on NH4CHO with CNO, which is known as ammonium cyanide, and he decomposed this. Means he broke down this, and he got a compound called as urea, which is NH2CONH2. Then you can say that Berzelius, who said carbon compounds cannot be synthesized, but Wöhler could synthesize an organic compound which is nothing but urea. So after him, many scientists started synthesizing organic compounds, and thus the devotion of synthesizing many carbon compounds today goes to the Wöhler. Hence, Wöhler is regarded as father of organic chemistry. So, who synthesized the first organic compound? Wöhler, which was synthesized. What was the first organic compound? Urea. It was from ammonium cyanide. Please remember. And who is called as father of organic chemistry? Wöhler is called as father of organic chemistry. So, these are the concepts comes in history when we study about organic compounds. Next, hope you are clear with the concept of history of organic chemistry. Who said cannot be synthesized, who coined the term, who is father of organic chemistry, who synthesized the first compound, which was the first compound, and from which it was synthesized. Okay. Next, moving on to classification of organic compounds. As I said that Wöhler was the one who gave the green signal to synthesize many organic compounds. Hence, many scientists started synthesizing lots of organic compounds, and so we need to categorize them into separate headings. So that's why we are going to have the classification of organic compounds. So we have different classifications. First classification is based on atoms present. So organic compounds are divided into two types. The one is hydrocarbon, the next is functional group compounds. What do you mean by hydrocarbon? Which are made up of only carbon and hydrogen. What do you mean by functional groups? Which are made up of compounds apart from carbon hydrogen. Example, you will be finding here carbon attached to oxygen. You will be finding here carbon attached to nitrogen. You will be finding here carbon attached to sulfur, phosphorus, carbon attached to halogen. So, halogen, this is X. So, if carbon attached to only hydrogen, they are called as simply hydrocarbon. If other than hydrogen is also found, like oxygen, sulfur, all other atoms are found, they are called as functional group compounds. So we have on list of 15 functional groups. We'll be talking about the next classes, but as of now we'll move on to the hydrocarbon. So again we have two types of hydrocarbon, which are saturated and unsaturated. Saturated means the carbon is satisfied with a valency. We'll be talking about in detail. So moving on to the saturated example is alkane. Alkane means you will have carbon-carbon single bond. Please remember. Whereas in case of unsaturated one, examples for unsaturated are alkene and alkyne. Alkenes are carbon-carbon double bond and alkynes are carbon-carbon triple bond. So So if carbon-carbon single bond is formed, called as alkane, double bond alkene, triple bond alkyne. So we'll now totally talk about or shift our concept towards hydrocarbon only. When we finish this hydrocarbon, then we'll move on to functional group. As of now, we'll talk about hydrocarbon. So hope you got the classification. So of organic compounds based on the atoms, hydrocarbon, functional group. Only carbon, hydrogen, hydrocarbon. Other than hydrogen, functional groups. We have 15 and here we have 3 alkene, alkene, alkyne. Now, the first classification was based on the atoms present, whereas the second classification is based on the chain. If compound is closed chain, you call the compound as closed chain organic compound or cyclic organic compound. If they are open chain, you should call them as open chain organic compound or acyclic or aliphatic. Example will here do itself. Consider this is a compound of carbon which is of straight chain. It has no cyclization. It has no ring, and this is an example of open chain. Whereas for the closed chain, you can write it like this. You can say the molecule is closed, hence it is cyclic molecule. So based on the chain length, based on the chain, we are dividing into two types: open and the closed. We are going to practice each and everything about the name in detail in the next slides. So now with this we understood the introduction and classification. Now moving on to the very important concept of organic chemistry is nomenclature. We have nomenclature for both hydrocarbon and functional group compounds. As of now we talk about hydrocarbon nomenclature. Then whenever we when we feel that we are hydrocarbon perfect in nomenclature of hydrocarbon, then we move on to functional group. So we'll talk about now the nomenclature for hydrocarbons. So before we move for the nomenclature, the meaning of nomenclature, right? The process of giving names. So everything has in the universe has certain name, whether it is human being, whether it is animal, or bacteria, virus, or any chemical, books also, anything whether it is living or non-living, anything in the universe will have definitely a name. So we should also have a name to the compounds, right? So how to give the name of any compound? It is designed by or set by an organization called as IUPAC. What is IUPAC? International Union of International Union of Pure Applied Chemistry. So what is the full form of IUPAC? International, I for International Union of Pure Applied Chemistry. So what is it? It is an organization which is responsible for setting rules and guidelines of chemistry. So according to IUPAC says if a compound has 1 carbon, you please call the compound as meth. If a compound has 2 carbon, you call the compound as eth. 3 carbon, pro, 4 carbon, bute, 5 carbon pent, 6 carbon hex, 7 carbon hept or sept. But this is most commonly used in chemistry and this is used in biology usually. Next is if it has 7 carbon, you please call them as oct, and if it is 9 carbon, non, and 10 carbon, dec. So please remember 1 to 10 carbon chain: meth, eth, pro, bute, pent, hex, hept, oct, non, dec. Meth, eth, pro, bute, pent, hex, hept, oct, non, dec. So this is about the IUPAC nomenclature. These are the rules. First rule is, please whenever you see the carbon, please call them accordingly. Right? Now this is not a complete name. Okay, this is the first step only. Please memorize this 1 to 10: meth, eth, pro, bute, pent, hex, hept, oct, non, dec. Now moving on to the very crucial step for how to write the name of any Please, if you want to write the name of any compound, Please memorize the rules. For hydrocarbon, we have only two steps. The first step is look at number of carbon atoms. So by looking at number of carbon atoms, you can say meth, eth, pro, but, pent, hex, hep, op, non, dec. Second step is look at carbon-carbon chain. First step is carbon chain, and second step is number of carbon-carbon bonds. Okay. If you find single bond between carbon, you please write as ane from alkane. It is derived from alkane. If it is carbon-carbon double bond, you please write as alkene. If it is carbon-carbon triple bond, you please write as ine. With the help of this two step only, you will be able to write the name of any hydrocarbon. Whenever you look at the any structure, please look at the number of carbon atoms. Second step, look at carbon chain, bonds, carbon-carbon bonds, single bond ane, double bond ene, triple bond ine. Right. With the help of these two steps only, we are going to write the name of any hydrocarbon. But in between, you will be having certain rules. So apart from these steps, we will also have certain rules. And the thing is, so just let's start. Before we attempt the names, we'll write what carbon makes how many bonds, what is carbon, and carbon makes how many bonds, we'll see. Atomic number of carbon is 6. 6 means first will have 2, second will have 4. That means carbon have only 4 electrons in the outermost shell. So according to octet rule, if an element have 8 electrons in the outermost shell, the atom is stable. As carbon is having only 4 electrons, it is unstable. You know what? Hence, it forms 4 bonds. Consider hydrogen is coming. Hydrogen comes with its own electron. So you see, carbon had only 4. Carbon had only 4, which was hence carbon was unstable. To make it stabilize, to make the carbon stabilize, carbon is binding with other elements. Like example, binding with hydrogens. Hydrogen whenever it comes with its electron. Hence, they are forming the bond. The mutual shading occurs here and here, here and here, here and here, here and here. You can say that carbon is forming 4 bonds. Each bond have 4 electrons. Now you can say that carbon now acquired 8 electrons. Hence, carbon becomes stable by forming 4 bonds. Hence, carbon always makes 4 bonds. Please remember, carbon always makes 4 bonds. So whenever you write the name, please make sure that you are attaching carbon with other 4s or 4 bonds. Now moving on to the practicing of hydrocarbon compounds. First step, atoms, carbon atoms. Second step, carbon-carbon bond. That's all. With the 2 steps we'll be going to write, but in between you will be having certain rules. Please remember this. Consider, I want 2 carbon. Okay, I want 2 carbon. And right? And we are talking about only hydrocarbon means this. Apart from carbon, you will be having hydrogens. As this carbon is making single bond, that's why I am writing here 3 hydrogens, because carbon always makes 4 bonds. 1 is with the carbon, 3 with hydrogen. Hence the valency with the carbon is satisfied. Again I should write it 3 hydrogens. You can see that. Now how to write the name? I told you first step is carbon atoms you look. If you have 2 carbon atoms, what do you call? It. Second step is carbon-carbon bond. If it is forming single bond, ane, double ene, triple ene. So it is forming single bond. Single bond is ane. Hence the name of the compound is ethane. Similarly,